Hey, hi everybody. Am I audible?
Yes.
Okay. Okay, so this is about solving your doubts. So, who is going first with the question?
Hello.
Yeah.
Yeah. Hi, I'm good.
Hi.
Actually, I have this doubt that we are given some problems, like some problem is given, and we are asked that write a solution as in order of log n or order of n,
Yes.
or some other order of n square. So, how do we how to solve those problems? I have gone through the lectures once, but I think I need to repeat all of them. So just how to approach these kind of problems when we are given
Okay.
such like orders. Yes.
Okay. So, firstly, there are not too many such questions because this was the first time you guys would be experiencing such kind of thing. So, we have put only one question in graded and one question in practice in week 2.
Yes.
Yeah. So, if you are given to try some solution that has uh, some order and order log and complexity, that means the expectation is to expectation from you guys is to write an efficient algorithm for that problem. So, every problem there are different ways to solve it. For example, if you have seen the binary search lecture. Okay,
Yes.
so binary search can be done only on a sorted array. You can perform search using binary search only on a sorted array.
Yes.
But that's not the only thing you can do. You can also do a sequential search. There, just iterate over the array one by one. You can do that, right?
Yes.
So there are two ways to search in a sorted array. Okay, now what is the
Yes.
complexity of sequential search? Suppose there in an array or a list with n elements, if you want to search an element that is not there in the list, how
Mhm.
many elements will you need to compare?
I have to compare everything in that list. Means
You have
all
to
the
compare
elements.
everything. So that means n elements you will have to compare. So the
Yes.
complexity is around order n, right?
Yes.
Upper bound will be order n,
Yes.
big O of n. Now, if you this array is sorted, so if you perform binary search, okay, how many operations will it require? The upper bound will be
Order of n.
log n. If you have seen the lecture and if you understand the binary search, then you will get this. If you have not seen the lecture, go through it.
No, I have seen all the lectures.
Okay, okay then. If you have seen the lecture, then binary
Yeah.
search, if you remember, we start from the middle of the array. So suppose the element is at the mid itself. Then the number of comparisons you did is only one.
Yes.
So that is the best case. But we are talking about upper bound. In worst case, suppose the element is not there in the list. Okay. So the element to search, then after mid, where will you search? In binary search?
I will check. I will compare with every element and
No,
one
that is
by
not
one.
binary search. Binary search is you compare the mid element with
Yes, and
whatever you
then
want to search,
then
then see if you will be searching in the right part of the array or left part of the array.
left part. Yes. Yes. Yes.
Okay, so so suppose you want your as according to the number you are searching, if you are searching in the right part of the array, then you again take the mid of the right part of the array.
Yes.
So if you will visualize this, this will be the I don't know if remember if sir has discussed the mathematics behind this,
Yes. Yes.
but
He have
yeah,
discussed
I
like
think he has discussed. So the number of comparisons, number of the upper bound will be log n in case of binary search. Okay, so when so in any question where we expect you to solve in log n, and it
mm-hmm.
is a question of searching. Okay, then we
Okay.
expect you to implement the algorithm using some flavor of binary search. Only then it will
Okay.
execute in log n time.
Okay.
The answer
Okay.
will be correct even if you do a simple search,
Mm-hmm.
but it will take more time. And our private test cases has about thousands of elements in the list. It could be
Okay.
10,000, it could be 20,000, it could be more.
Okay.
Okay, so you if you write a linear search program there where binary search is expected, your program will time out.
Okay.
Because sir has also discussed this in lectures that log of 1,000 is, if you guys remember, log of 1,000, log 2
Around
of 1,000 is 10,
10.
around
Yes.
10, because 2 to the power 10 is 1024. So got it?
Yes. Okay. Similarly, when we have this order of n plus r, so it can be solved using insertion sort or something like that,
So
which
that is
goes
not,
at.
yeah, if you try to sort it, so that question we have given you in practice assignments, because the exact
Yes.
same algorithm that is required to solve that problem is not discussed in lectures. But everything cannot be discussed in lectures. So this is the way
Yes.
to learn through some questions and some practice assignments, all these things. So
Mm-hmm.
that question is the solution for that question will be a flavor of counting sort. So try to, so if you remember the question there, the elements can only be in a fixed range.
Yes. Yes.
Okay, so that means you can count if you, so suppose there are 10,000 elements and the range is
Mm-hmm.
only 1,000. So there will be a lot of elements, those will be repeated a lot.
Yes.
Yeah. So so the best way could be to count those, to store count of each element, those
Okay.
1,000 elements, and then
Okay.
just generate the list from that. I'm just giving you the idea. Try to write a program with this idea.
Okay. Okay.
Yeah. Yeah. So any more doubts?
Yes. Can you once explain this practice assignment question one?
Okay, just a second. Just a second. I'm opening that. So what is the question?
It is about founding this the complexity.
So programming assignment are you talking about, or something
No,
else?
practice assignment. I'm talking about practice assignment.
Practice
Where
objective or programming?
it is objective, not PPA. The practice assignment. Practice assignment two.
Let me share my screen.
Ankur,
Yeah.
share the front end. Otherwise, students will get confused. Don't share this back end view UI.
Okay. Okay.
Yeah.
But from front end, I don't think. Oh, I have access.
Yeah, you have.
Okay.
Using same CS2002, you can access that front end link.
Mm.
Shall I share my screen? Yes.
Yeah, just go ahead. Actually, I was using.
Okay, actually,
So, Omkar,
I
will I
can't.
need the webcam?
No, webcam is not required.
Then I will use
So
my regular laptop
yeah, you can use.
because there was some issue in my laptop, so I configured another one. And here I have
Okay.
to open all the links. Like nothing is saved.
Okay, if that's the case, just hold on. I will give you the link. You have already
No, no.
logged in through
Just
CS002,
it will
right?
take just 5-10 seconds
Okay,
from
that's
that laptop.
okay, fine. And only thing is, you'll have to ask Karthik again to make you co-host on with that account.
No, same account will be there.
Okay, fine.
Actually, I cannot share because only
Yeah,
hosts are
that's
allowed to
the
share.
thing. That's the
Yeah,
thing. You will not be allowed to share.
yeah,
Just give Ankur 2 minutes. Just a
Hello.
minute.
fine.
Hello, Umka, yeah?
Yeah, Karthik. Just 1 sec. I mean, just be here for a minute. Ankur is
Okay.
switching his machine. I'm not sure whether you have either. You may have to make him co-host again.
Okay, okay.
Yeah.
No, I.
Yeah, Ankur. Now you're co-host on both machines, so you can use either.
Okay. So, am I audible?
Yes,
Just a second. So you are saying PPA 2.
practice assignment too.
Okay. Just a second. Hey Omkar, can you just check your mobile once?
Yeah. Okay. I'll just ping you. Just hold on. Yeah, Ankit, check it.
Sure. Thanks. So this one,
Yeah, this one also
Because
I
he's asking
asked.
about practice assignment.
But this also I asked earlier. But
yeah,
yeah,
this
this right now
assignment
this one.
too. No,
Yes, this one. So
okay. So you didn't understand this, right?
no.
Okay. So actually, when there is recursion, writing recurrence relation for recursion is easier than writing recurrence relation for a like a iterative program. Okay.
Okay.
Yeah. So here, if you see that your function will be called for n, right?
Yes.
And every time the function is called, if n is greater than 0,
Hmm.
we will call the recursively the same function twice
Yes.
for n minus 1,
Yes.
right?
Yes. Yes.
Okay. So whatever time it will take for n, it it will be equal to twice the time it will take for n minus 1, because we are calling the same function for n minus 1 twice,
Okay.
and one step for adding the results from both the calls. If you can see, there are two calls,
Yes.
n minus 1, f1, n minus 1, right?
N minus one. Yes.
So these both will return some result.
Yes.
At some point of time they will, not immediately. Okay. So they
Mhm.
will return result at some point of time, though that result will be added. So there's one more step involved here, right?
Yes.
Got it? So that's why
Yes.
the relation will be Tn is equal to twice of Tn minus 1 plus 1.
Is this plus one? How is it coming? This plus one.
Yes. So that's what I was saying, that this will return fun n minus 1 will return some result.
Yes.
So suppose n is equal to 1. Suppose let's run this function for n equal to 1.
Okay.
Let us run that. Okay.
Mhm.
So when n is equal to 1, uh, if statement will be false. So we won't go there. We will come to return the last
Yes.
line.
Yes.
Okay. And what will this be? Return fun of 0 plus plus fun of 0.
Fun of 0.
And what will fun
One.
of 0 return, that you should tell?
One. One. One plus
Fun
one.
of 0 will return directly 1.
One. Yes.
Okay. So there is two fun of 0 at two places. Both
Yes.
at both the places 1 will be returned.
Yes.
Okay. So now 1 plus 1. What will be returned?
Yes.
Fun of 1 will be 1 plus 1, 2.
Two.
So how
Yes.
did you get that 2? How did you get that 2? By adding 1 and 1, right?
Yes.
So
Yes.
that is the one step. Every time you will be adding that.
Okay.
Either you can, no, actually, no, sorry. This one is coming from this is just one. Just a second. I was assuming that the correct answer is twice of t into n minus 1. Just give me a second. And this is practice assignment, not graded, na?
No, it's not graded assignment. It's a practice assignment.
Okay. So hello.
Yes.
Yeah. So I think this one is the last step. So just put n is equal to 0 in this relation. Twice
Okay,
of t n minus 1 plus 1.
yeah, at the end it will be 1. We will be left with 0. Is it so that we have plus 1?
Yeah, that is the case. So the one that I was discussing, that there is one more step that will be counted as well. When you will resolve this twice of t n minus 1 again with n minus 2, there will be one more one will be added there when you will resolve it. Don't see
So,
this as just so this one is only for tn. For tn minus 1, when we will resolve it into n minus 2, there will be another one more step will be there. Okay.
actually, I'm not getting it.
So you will have to like extrapolate it from 0 and 1, then you will get it. What will be just insert just write this relation with n equal to 0, then n equal to 1, then n equal to 2, then you will get it. What will be t of 0?
It will be just 1.
Just it will be just 1. So this relation
Yes.
will return 1, right?
Yes.
What will be t of 1?
It will be 2.
it will be 2, right?
Yes.
T of 1 will be no. You are giving the fun of 1. I'm asking about T
Oh,
of 1.
okay. Okay, T of 1. Okay,
Yes.
T of 1 will be 2T0 plus
Plus
1.
1.
Yes.
Got it?
Okay, so the correct answer is this plus 1, the fourth one.
Yes. 4th and 5th, anything. No. 4th one.
No.
Yes.
And how to calculate this time complexity then with this? How is it coming order to the power n?
So for that visualization, okay. So I can explain you how to visualize that, but mathematically you can calculate that too, right? The way sir has explained how to calculate this mathematical recurrence relations, right? So I can help you visualize through this question.
Mhm.
So if you see, for every function call, we are making 2 more function calls.
Yes.
So we are doubling it, right?
Yes.
We are making double function calls for every function call.
Yes.
So every time we are doing it into 2, 2 into 2 into 2 into 2.
Okay.
So that's why it becomes 2 to the power n. 2 into 2 into 2 4 times will be 2 to the power 4.
Because we are adding the same function every time.
We are not just adding, we are calling also.
Yes, we are calling also.
Okay, and that in turn will call twice again. Fun n
Okay.
minus 1 will call fun n minus 2 2 times, and for the second fun n minus 1 will call fun n minus 2 2 more times. So fun n minus 1 n minus 2 will be called 4 times. Got it?
No, what did you just say?
I said fun n minus 1,
Yes.
it will call fun n minus 2 how many times?
Fun n minus 1, it will call 2 times.
And the second fun n minus 1, it will call fun n minus 2 how many times?
Again 2 times.
So fun n minus 2 will be called how many times?
4 times.
Sorry, fun n minus 2 will be called 4
Yeah,
times.
4
4.
times, no? Yeah.
Yes. So that's what I'm saying.
Oh, it will be raised in the power of 2. Okay.
So this is how, this is just the visualization. This is not mathematical proof. Mathematical calculation you can do easily. Sir has already explained that in the videos.
Okay. Yes, yes, explain actually.
Okay.
Okay.
So this plus 1, this will be accounted for both the things that I have told, the plus and the return 1. In the last step, there's only 1, and in every step there is a 1 for 1 addition.
Yes.
Got it? That's why it's a plus
Yes.
1. So don't consider this plus 1 as only 1. This is not just 1. This will be for every tn. It will be. When you will resolve
Okay.
tn minus 1, it will be twice into twice of tn minus 1 plus 1.
Plus 1.
Okay, got it?
Yes. Yes.
So there it will become plus 2.
Yes.
You got it? So it will be for this
Yes.
plus also, between fun n minus 1 plus fun n minus, and 1 is for return 1 also.
Okay.
You got it? How this plus 1 is there?
Yes. Yes, I think I can do it now. Yes.
Okay.
Okay.
Okay, so if you guys don't have any questions, so how is your experience with? So have you guys started with week 2 assignments? Everybody? So did you practice any of the sorting algorithms, simple ones that Sir has taught in the lecture?
Yes, that.
Yes, Manish, are you saying something?
Sir, I have a doubt in one of the videos. Yeah, yes, sir. I have a doubt in one of the videos. Sir, while sir was explaining measuring running time, there was a concept of exchange of pair of values, like xy is equal to y. And sir has used one third variable that I'm not.
So do you guys have any questions in specific in mind that you guys want us to discuss either today or in the live session, upcoming live session that we'll be taking on Saturday? Any question is related to the course that we have published till now? May not be in the PPAs or graded programming assignments.
It will be nice if we can have more question with this order, like when we are asked to give a solution with some given particular complexity. If you can have such questions,
Okay.
because this we have not done earlier, I think.
Okay. But that is just we can do that. Actually, that is a good exercise.
Yes, if you can do it now, it would be nice. Because in the lectures, actually, sir is explaining, sir is taking the code and then he's telling about the complexities and all. But here we are given complexity and then we are asked to write the solution.
Yes. So you have to think of this a lot of solutions, right?
Yes.
And out of which you have to like you have to calculate the complexities also of each solution that you have thought,
Yes. I think yes.
right?
Yes.
So that is everywhere. That concept is everywhere. If you so see, sorting is a problem. Sorting integers is a problem. Singly, if you
Yes.
talk about. Okay, now that simple sorting we have studied for a week, and
Yes.
there will be more in the some more algorithm in the upcoming week, and there will be a lot of algorithms that is out of scope of the syllabus for sorting itself.
Okay.
So a single problem has multiple solutions. Okay,
Yes.
yeah, and now if you talk about there are pros and cons of each solution. So till now in week 2 what sorting algorithms have we studied?
We have this binary sort, selection
No,
sort,
no binary
insertion
sort.
sort.
Binary search is there.
Sorry, binary search. It's selection sort and insertion sort, and then there is this merge also.
Yes.
Mm. So
So
binary searches.
yeah, so there itself there are these algorithm itself have different complexities.
Yes.
So everything, if you think it in terms of this, that every problem we give, okay, it is also a problem that can have multiple solutions. So sorting is also a problem that can have multiple solutions. Out of those solutions, three of those we have studied in week 2 lecture, right?
Okay. Yes.
Right. So now in insertion sort, and just let's compare insertion sort and merge sort. So insertion sort takes the upper bound of insertion sorted order of n square, right?
Yes.
And for merge sort, it is
Merge. Merge. I don't remember.
order n log n.
N log n.
Okay. So the efficient algorithm among these two is merge sort, right?
Yes.
But merge sort we require extra space. This is the catch, right?
Okay.
So everywhere you will find these kind of pros and cons for different solutions. So if we are not focused, if we assume that we don't have any problem with space, we have a lot of space and we can use as much space as we want, then we will
Mhm.
always use merge sort,
Okay.
right? But if you don't have that much space, then you will have to think of some other solution.
Yes.
So this is what, that's why the questions are given in that way, so that you think of better solutions for the same problem,
Okay.
right?
Yes.
So in your week 1, you would have you are given a lot of programming assignments,
Mhm.
but there we just wanted you to revise your Python concepts.
Yes.
We didn't want you to think about the efficiency of your program. That's why there you won't find that in your solution is expected to run in this upper bound, right? The
Yes.
whole purpose of studying algorithm is for designing efficient algorithms. That's why we are we have given bounds for a few questions to start with, right?
Yes.
Okay. So we will discuss that. We will pick on Saturday. We will pick some questions that has about 4 to 5 ways or 2, 3 ways of solving it, and then we'll discuss the complexity of each solution.
Okay.
Yeah, we can do that.
Yeah, hello, sir.
Yeah,
Sir, I'm audible.
yeah, little bit louder would be better.
Okay, yes. So I have a doubt. I mentioned in the chat.
Hello.
Yes, sir. I have written in the chat box.
Okay, you have given your problem in the chat.
Yeah, I think my voice is not clear. That's why I mentioned in the chat.
Now
Please help
it
me.
is clear.
Okay. Okay, sir.
So exchange a pair of value.
Yes, sir. Why I mean, just I'm confused in like using third variable t.
Sorry, I lost you. You are confused in?
So using third variable t. Why? How using third variable?
Okay, why do you need to use third variable in swapping or exchanging two
Yeah,
values?
xy is equal to y comma x in that one.
Okay, so suppose x is equal to 2 and y equal to 3, right?
Yeah. Yeah.
Now x is equal to 2, y equal to 3. You have to make y equal to 2 and x equal to 3.
Yeah. Okay.
How will you do that?
Sir,
Just write x equal to y, then write y equal to x, right?
mm,
Sorry, I don't have a pen pad today, so I'm sharing on my screen, and bear with whatever I in whatever way I write. See, is it visible?
Yes, sir.
Okay, so this is our state, initial state. Okay, got it.
Yeah, okay.
And this is what is expected, right?
Yeah, yes, sir.
So how are you planning to solve this? If not by that, then you are saying why are we taking third variable? Why don't we do just like this?
No, no, sir. I'm saying I got the why we need third variable, like for
Okay,
reshuffling of, but sir, how that is implementing that I'm not
how
able to understand.
how that is implemented internally?
Yeah,
So so you got that third variable is required because if we assign one variable with the other variable, that value will be
yeah,
lost, right?
yeah. I got that.
So it's very simple. So whatever value you were losing, just store it somewhere else. So it's simple, na? Suppose you are given two glass of water. One is red, one has red liquid, and one has blue liquid. Okay, you
Yeah,
want to exchange the liquid.
yeah.
How will you do that?
So we need third one third glass.
So you will put one red one or blue. Suppose you put the red liquid in some other glass or bowl, whatever.
Yeah.
Okay, then your first glass that had red liquid is empty now.
Mhm.
Now you can put blue liquid in it. Only then. So even if it is not empty, here it's not exactly similar. Here we copy it. Okay.
Okay. Okay.
So now in that glass you will replace it with blue liquid completely.
Mhm.
Now you can put the red liquid from the third one to the second one again. So this is how it happens in memory. What happens in memory is that when you say a temporary third variable, when you take so you are saying what happens behind this,
Yeah, yes.
uh, behind x comma y is equal to y comma x, right?
Y comma X. Yeah, yes.
Yeah,
Okay.
it employs a third variable internally. It won't be able to do without a third variable.
Okay.
So Python is a language where they have given you an option to write your code in this way. For the correctness, they will take care of it. The correctness of this code. Internally, they will take care. The language will take care of that the values are swapped and nothing is lost. But if you are not given in some languages, if when you are not given such option to write the code, you have to take a third variable and you have to write it like this. Python internally would also be using the same concept. This one. So there's nothing too special about that in Python. They are just giving you a way to write it easily. Got it?
Yeah, okay, sir.
All right, guys. So if there is no new questions, then we can close the session. So Pooja, Manish, Sherian, if you have any questions, ask, or else we can close the session.
Yeah, if you can please explain this, the question I asked first, this PPA, the one with the order n plus r.
Okay.
Ankur?
So what is the solution till now that you have thought?
Actually, I'm really actually confused in this orders right now. So I will be watching the lectures
Don't
all
worry
over
about
again.
order. Don't worry about order. Just tell me how will you solve that problem without considering the order.
Like this can be, it's a sorting problem. So we can start by just like for example, we can start by taking the list and comparing the elements. One can be that, other one can be using this midpoint and comparing, like if the select this one, this two I can think of.
Two means
Means the insertion sort I'm thinking, and this can be
okay.
solved using that.
Insertion sort, merge sort, anything you can employ that you have studied.
Yes.
Now suppose
Anything.
I give you a new question that your list has only two elements,
Mm-hmm.
0 and 1.
Mm-hmm.
Not two elements. Your list can have only two type of elements, 0 and 1, but
Mm-hmm.
it has 10 elements, 0 1 0 1 1 0 1
Mm-hmm.
1, some order. Okay.
Mm-hmm.
And you want to sort it. Sort it means all zeros should be before all ones,
Yes.
right? How will you do that easily without any sorting algorithm?
Without any sorting algorithm.
Yes, think of it. There are only two elements,
There are only two elements, and then I will just
two type
compare.
of elements, not just two elements, two type of elements.
Yeah, then we can simply compare with uh, both of them. Like if it is equal to this or this, I think.
But there can be more,
Okay.
not just two elements. Type is there can be only two type of elements, but there can be more
Mhm.
elements. I'm saying.
So then, like we can start. Yeah, this we'll simply start taking from list, and we'll start comparing, and then
Okay, I'm
it will be
sharing
like
my
a sort.
screen.
It will be like a sorting only. Yeah, actually, in this problem, I was confused because here you can see that there is this range is given, like one side is this closed and the other side is open, and then what means this r is between up to 100 and n is such that, so means why this range is implemented means, so this is making it confusing. And then it is given that it should be order n plus r, and if it is order n plus r and n is already bigger than r, so it should be order n only, right?
So it is order n only. But order n or order n plus r, you can write order n plus r. That's not an issue. So here value of r is 1000 just for the sake of simplicity. We have put it small. The other thing is we cannot give you r is around 1 lakh. R is equal to 1 lakh and n is around 50 lakhs or 10 to the power 8. So sir has been talking in lectures like 10 to the power 8 and 10 to the power 6. Okay. So the actual scenarios, the actual scenarios could be anything. It could be 10 to the power 8. It could be 10 to the power 12 also. Okay.
Okay.
So, but for the sake of simplicity and understanding, we have given r as a small. So here you will feel that r is insignificant. What if r is 10 to the power 6 and n is 10 to the power like 12? Then what? Then it won't be such insignificant, right?
But even if it is given much greater than, then I thought it should be insignificant. Means
No, not
if you
always.
calculate the order, then isn't it?
If you calculate the order, then it makes a difference. When they are very big, so it's about perception, right? So generally, constants we don't use in upper bound, but R is not constant actually. That is
It's not.
bounded by 1000 just for the sake of simplicity, just for you guys to understand and focus on the main concept, and we cannot give you very big test cases. That's why, right?
Yes.
So now, can you see the screen?
Yeah, I can see it.
Okay. So suppose so this is your array, right? How will you sort this?
So we normally start with this the zeroth element,
Yeah.
and
No,
we
don't think in terms of sorting algorithms that we have seen in the class. This is very simple problem. This doesn't have more than two elements, two type of
mhm,
elements. You won't find anything other than 0 and other than 1.
yes.
Just try to use some counting. Can you do some counting and just sort it?
Counting means we'll see
How
if
many zeros are there
4,
and how many ones are there?
5.
So if you just store somewhere this information,
Mm-hmm.
now can you sort it with this information?
Yeah, we can write like
You create a
simply
new array where 4 times you will write 0,
0,
then 5 times you will write 1.
1.
Okay, got it?
Yes.
Got it or not?
Yes,
So
but
to count 0 and 1s, you have to see the
mhm,
complete array only once.
yes.
Take a variable, c0, count of 0, and another variable, count of 1.
Okay.
Okay, and iterate over this array. Whenever you find 1, increment c1. Whenever you find 0, increment c0, right?
Okay.
At the end, you will have count of zeros in c0 and count of ones in c1.
Yes.
Got it?
Yes.
And after doing that, just in the same array or in new array, just print whatever the value of c0 is, whatever the value is here. Print those many zeros, write those many zeros, then write those many ones. That is the value of z1.
It will be like using a loop or something, or simply printing.
Simply just replace in the array. I am saying, add it in the array. So this is 4 and this is 5, right?
Yes.
So first add 4 zeros in the array, then add 5 ones in the array. You will get the sorted array. Starting from index 0, right?
Yes.
Got it?
But you have to, even if you put, then you have to use a loop. How else you will put like, or just adding means
You
like
have to use a
appending.
loop. If you are talking about the program, then you are right. I'm not
Mhm.
talking about the problem, actual problem. I am just talking about the question that I gave you.
Okay. Yes. Yes. Yes.
There you don't need loop because you know there are only 2. You got it or not?
Yes. So I can like 4 times I will keep adding zeros, and then for 5 times I will be adding 1.
In the array.
Yes.
What if I tell you that now the array can be 0, 1 or 2? 3 values can be there.
Then we will again count the value of 2's similarly to 0 and 1.
Then you will need how many variables to count?
3.
3 variables to count, right?
Yes.
Can you do this for R?
Because R is less than 1000, so it can be like almost 1000. There will be 1000 variables.
So if there are 1000 variables, what will you do? Can you take a list of size 1000?
But it will be big.
Yeah, it
Yeah,
doesn't
but we
matter.
can take a list. Yeah, we can take a list.
Yeah, you can take a list of size 1000, and every index in that will be storing the count for that number, right?
Yes.
And to make it simple, okay, so can you see see my browser, or is you are still seeing the paint?
No, I can see a collab notebook, I think.
Okay, so now you are saying why are we given this type of bracket, right?
Yes, and
So
and
this
also
is
the
this
yes.
is the standard notation. If R is if R is not included, then it is
Yeah,
a
it's a open bracket. Yes.
open bracket. So that means I is between 0, I can be equal to 0, but I cannot be equal to R.
Mm-hmm.
So suppose R is 10, okay,
Mm-hmm.
so our range will be 0 to 9.
Yes.
When R is 10, our range, so take this question only, when R is 4, our range will be 0 to 3.
3. Yes.
Okay, so if you take a list of size 4, what will be the indices of that? 0 to 3, 0, 1 to 3?
0 to 3. Yes.
Yes, so just those indices are actually the values, and this list will store the count of those values. Think in that term.
Okay. Okay.
Now if I will explain you more than this, it is like explaining you the program, then you won't learn anything.
Yes.
If until you try by yourself, you won't learn.
No, I'll try this. And if
You got the point?
yeah,
You got the concept?
yeah, I got the concept. I will now try it. If you scroll below and come to the sample test, you see that in for me in the test case, you see the expected output is 0 0. Okay, because it's okay. Input is too long. That's why. Oh, I thought why everything is 0.
No. So how many zeros are here? 1,
Oh yeah,
2, and
actually
3.
yeah.
That's why
Yeah,
3
now
zeros.
yeah, no. Actually, the below one, I thought everything is 0.
No.
You see this scroll now. In my, I don't see scroll, and I have to do it by my hand. So now I see. Okay. It's. I thought there is some issue in the output. It's okay actually.
Yeah.
Yeah.
Got it?
Yeah.
Okay. Yeah. Any more questions? Manish? Okay.
So just one thing. So if there is some issues, we can in the Saturday session. Will we have this question answer, or it will be just the coding, slide coding?
We can have both. No issues.
Okay. Okay. Thank you. Thanks a lot.
Yeah. Okay. So Omkar?
Yeah, Ankur.
Yeah.
Also, can I ask one more question? Like
Yeah, go ahead. Go ahead.
these type of question, I know if I Google, I'll find anything. But can you suggest me a source like which is best for practicing these kind of questions?
Source means I didn't understand. You need
I
a
mean,
ID.
like if I Google, I'll find many websites and links. But according to you, which one is a good one to follow for like practicing this type of questions? The order and complexity. I think I'll need a lot of practice.
I think you should follow the books that are being given there. Okay.
Okay.
So
Okay.
there they will teach you in the order that will help you. If
You have You have,
in the,
Acha, you have listed the books, yes.
yeah, we have listed a few books on the page. You will find it
Okay.
in the introduction section.
Okay.
Course
Okay.
introduction,
Okay.
right?
Actually, I
Course
was asking
about
for
the course.
the programs actually where we can find, problems and such that.
Yeah, in this books you will find a lot of problems,
Okay. Okay. I'll check.
right? So if you Google, then you will find there's a vast community,
Yes.
and there are a lot of websites, but there uh, the problems may not grow from easy to hard. Okay, but in these books it will be in sequential order, everything.
Okay. Okay. I'll check it.
Yeah, you will get confused. The level of problems on the internet could be something that would involve a lot of concepts that would have not been taught till the week you are in, right?
Mm-hmm.
If you are in week 3 or if you are in week 4, there will be a few concepts that would be taught, and there could be, you could find a problem on internet that would require more concepts than that.
Okay.
Then you will get confused. So if you follow these books and the structure that sir is following, then you won't find any issues.
Okay.
Yes.
Thank you.
Okay then. So if there are no more questions, I think we can close this now.
Yeah. Bye. Okay.
Yeah. Good day.
Artik, we can close the session.
Okay, Umar. Thank you.
Yeah, thanks.